So, hier is ons weer met ons vriend Pythagoras, again the Pythagoras, so you better get to know him now. Wat sê Pythagoras in essensie? As jy enige reghoekige driehoek het en jy het enige twee van die drie sye, sal jy die derde een kan uitwerk. So wat gaan die Pythagoras voor gebruik? In 'n reghoekige driehoek, as ek enige twee sye vir jou gee, kan jy die derde sy uitwerk. What does the theorem of Pythagoras say? If I have a right angled triangle and I've got any two sides, I can work out the third one. It doesn't matter which one. Any two sides. Kom ons sê gou weer wat sê die stelling van Pythagoras. So in 'n reghoekige driehoek sal die vierkant op die skuinsy, is dit die vierkant? Nee. Die vierkant op die skuinsy gelyk wees aan die som van die vierkant op die ander twee sye. In any right angled triangle, the square on the hypotenuse side, that's not the square, that must be squared. The square on the hypotenuse side is equal to the sum of the squares on the other two sides. Goed, waar begin ons as ons aan Pythagoras wil raak? As jy nou eers besef, this is the correct tool I must use Pythagoras. You start off and say my entrance ticket for Pythagoras is T is gelyk aan 90. When it's gegee, it was given that it's 90. That's why I've got my ticket to go into Pythagoras' theorem. The theorem of Pythagoras says the square on the hypotenuse side, which is SM. Can I write MS? Ja, jy mag maar SM skryf. SM, MS maak nie saak nie. Die vierkant op die skuinsy is gelyk aan die som van the sum of the squares on the other two sides. Som van die kwadrate op die ander twee sye. Kwadrate, vierkante, selfde ding. Die vierkant op die skuinsy is gelyk aan die som van die vierkant op die ander twee sye. Die kwadraat op die skuinsy is gelyk aan die kwadraat op die ander twee sye. The square on the hypotenuse side is equal to the sum of the squares, TS and TM. And I can write ST and I can write MT and I can swap them around. Reg so. Nou gaan ek invervang. Maar toe sê ek vir jou gister, vorige keer, wanneer jy dit doen, kan jy dan sommer van die begin af vir my sê, as ek nie die skuinsy wil uitwerk nie, if I don't want the hypotenuse side, because I have it, then I can make a subtraction sum. So jy kan of dit doen, of ons kan dan nou gaan vir die aftrek sommetjie. That's the one I taught you. So if you want TS, then it will mean the hypotenuse side, which is SM, subtracted the other side, TM. Dit moet SM eerste wees. It has to be the hypotenuse first because it's the longest. Hypotenuse squares the sum of those two. So if I don't want the hypotenuse, I want this one, it must be hypotenuse squared minus that one. Want dis mos nou 'n vergelyking as die een oorgaan en die ander een uitgewerk moet word. So I now have SM, that is 25, that I'm a square. And I've got TM, that's 15, that I'm a square. Onthou weer, MT, TM, selfde. But it has to be the 25 first, the hypotenuse first, en dan die reghoek sy. En dan vat ek my sakrekenaar, en ek gaan werk uit, as ek hom nou net hier kan vind. So it's going to be 25 square, which gives me 625. And 225 when I work it out. And when I subtract that, I get 400. So TS squared, write it all the time and you can't go wrong, 400. How do I now get just the TS? Wat gaan ek doen om die kwadraat weg te kry? In an equation, what I do on the left, I do on the right. I want to get the square away, so I square root. Opposite of squaring is square rooting. Teenoorgestelde van kwadraat is 'n vierkantswortel. So TS is dus gelyk aan sakrekenaar sal vir jou sê dis 20. 20 mal 20. Finished with the sum and it's about 1, 2, 3, 4, 5, 6 marks for that answer. Good. Give or take. The other one that I gave you for homework was I have to find the hypotenuse side. As dit die skuinsy is wat jy moet gaan kry, gaan jy sê AC kwadraat is AB kwadraat plus BC kwadraat, want dis wat Pythagoras sê. And now I hear you screaming, no, I have to first say what's my entrance fee. Angle B is 90, because it was given, that's why I've got the entrance for you to go to, Pythagoras. Is jy met my mense? Altyd eers moet jy sê, hoekom mag jy hom gebruik? Now, remember I said to you, the degrees you don't have to put there, but you have to put the little copy there. Jy moet die copy op die hoek sit, anders is dit nie 'n hoek nie, dis 'n punt. That is a point, that is an angle. So maak seker. All capital letters. Jy kan nie met klein lettertjies werk nie, dis nie sye nie. AC is a line. Small letters mean something else in triangles. Okay, so met ander woorde, ek weet nou ek soek die skuinsy. Kom ons sê hom nog een keer. Die vierkant op die skuinsy is gelyk aan die som van die vierkant op die ander twee sye. The square on the hypotenuse side is equal to the sum of the squares on the other two sides. You can swap these around, it doesn't matter, because they both are right angle sides. Hierdie is altyd die reghoeksye, die skuinsy staan links. As dit die aftreksom is, moet hierdie eerste ene die skuinsy wees. This has to be your hypotenuse side. You can't swap them around. Can you swap these around? Ja, jy mag maar. So ek vervang nou in vir AB met 20 and for BC with 60. Do you have to put the meters there? I would prefer you don't because you mess it up. If you're going to write meter square, you're going to want to square it again because the square is at the meters. So do it on the calculator again. 20 times 20 en 60 maal 60 gee vir jou 3600, wat vir jou sê AC is 4000. And when you think you're clever, just double check yourself and make sure that your answer is correct, especially in an exam. So 4000, if I square root that, my answer is not going to be an accurate answer. The answer is going to be 63,24555 what. And remember our arrangement, as jy nie weet op waar om af te rond, dis altyd 2. If nobody said anything, you round off to 2 decimals. So now, just remember, let's just do all of it together. To get the square away, you square root. To get the square away, you square root on both sides. So then AC is the square root of that gives me, in other words, 63,255, because this 5 makes this 4 a 5. Nou gaan hierdie aan en ons het al daaroor gepraat. So what did we solve? What does Pythagoras do? If I start off and I've got two sides, I can always get the third one using Pythagoras. And when you go back, you can go right there, 63,25. And you can go right here. The one that you got here was 20, so that you can see afterwards. Wat ek oorspronklik gehad het, was alles wat jy in potlood gehad het. My groen is jou potlood. En jy, dit wat jy gaan uitwerk het, sit jy daar in kleur dat jy mooi kan sien. Dit was gegee gewees, alles in groen. Wat ek gevind het, was in rooi. A good technique in geometry is, whatever I had originally, I put in your pencil. My green will be your pencil. And then whatever you find out, write in a color pen or highlight it. So afterwards you can see everything that was in green was given, and everything that's in another color was what I found out. Dit is 'n baie goeie tegniek wat jy kan gebruik vir meetkunde. Alright, so now it's getting more and more interesting and difficult. Soos wat jy nou al agtergekom het in wiskunde, ons begin met die basiese. En dan partykeer raak dit nou 'n bietjie moeiliker, want onmiddellik dan dink jy, wat gaan nou hier aan? What is this now? Nou het ek 2 driehoeke. Now I have 2 triangles. But very most importantly for a grade 8 child is I'm busy with Pythagoras, and I can be because it's a right angle triangle. But now I've got 2. And they joined. So this line AC belongs to both of them. Hierdie lyn AC verbind nou hierdie 2 driehoeke. Daar's 2 reghoekige driehoeke. En hulle het 'n maatjie wat hulle saam het. Hulle het 'n gemeenskaplike sy. They've got a common side that they share. In this triangle, ABC, AC is the hypotenuse side. En hierdie driehoekie is AC die skuinsy. En hierdie driehoekie is hy nie net die skuinsy nie. In this triangle, the slant side, the hypotenuse side is AD. Sien jy dit? So, in which triangle will I start? Where can I have enough do I have enough information to start? If I want to try this triangle, I only have one side. Gaan dit werk om Pythagoras te doen as ek een sy het? Glad nie. Wat sê die reël? Jy moet 2 sye hê om die derde een uit te kan werk. The rule for Pythagoras is you've got to have 2 sides to find the third one. So this triangle, I can't start with this one. Can I start with this one? Yes. There's a 3 and a 4, and I can work out the third side. In that triangle, I can say B is 90. And also a good idea is to say, I'm going to work in triangle ABC. So ek sê daar, in triangle ABC. So that everybody, the teacher marking, can see I'm busy with this one. I have angle B is 90. Dis my gegee, waarmee ek met Pythagoras kan aangaan. The reason I can work with Pythagoras is the 90 degrees. So I'm going to work out this slant side, so daarom is die skynsy kwadraat gelyk aan die som van die ander twee. If I want the hypotenuse side, it's the sum of the other two. If I don't want the hypotenuse side, it's going to be a minus sum. So in this case, to find AC, it's going to be AB squared plus BC squared. So it's a mark for writing down the theorem. Nou vervang ek. So AC kwadraat is, AB se kwadraat, AB wat 3 is, en BC wat 4 is. En dan gaan ek uitmaal, 3 mal 3 is 9, 4 times 4 is 16. So AC squared is equal to 25. Dan moet jy gaan al twee kante gaan vierkants wortel to get the square away. I root both sides and I've got AC equals 5 is the square root of 25. So now I can go back with my color pen on the sketch and say this is 5. Now there's something that I want to show you and tell you that a grade 12 child, if I showed him 3, 4, he would immediately tell me that this is 5. Because it's the golden triangle, the very first one that you did with those little blocks that you drew over there. Die heel eerste enetjie wat jy gedoen het, was daai goue driehoek, die goue driehoek. This is a very specific, particular ratio, the golden ratio, die goue verhouding van sye in 'n reghoekige driehoek. En as jy in graad 10, 11 en 12 ooit hierdie scenario kry en jy sien, aha, ek kan dadelik sê dis 5, dan mag jy. Jy kan net dadelik vir my sê dat hierdie AC 5 is. Immediately you can tell me that it's 5 because Pythagoras said so, and you would get full marks, although you didn't do all of these steps. Only for the golden triangle. And also, met ander woorde, as ek vir jou sê hierdie is 5 en hierdie is 4, gaan jy dadelik vir my kan sê dat daai is, yes, you're right, 3. Because 4, 3, 5 all go together. Want dit is jou goue driehoek. En jy hoef net te sê, hierdie sykie sê nou maar is XI. XI is gelyk aan 3, want Pythagoras sê so. So I want to leave it in your mind. For now, stick to the basics. But that's always going to happen. Dat jy as jy goue driehoekie sien, en jy is in jou volgende standaards, mag jy dadelik net die antwoord gaan skryf. As jy dit kan weet, en dit kan altyd met 'n rede byskryf, mag jy dit ook doen. Maar, sê nou net ek vang vir jou uit, en ek sê 4, 5. This cannot be 3. If it's the golden triangle, it has to have the hypotenuse side 5, and that's not the hypotenuse side. This one will be much more, because remember it's the longest. You're going to have to square and get the answer, which would be 41 square root, because you're going to have to work it out. I'm not going to show you that now. Just to know, if I give you 4 and 5, it's not always going to be 3, unless the 5 was the hypotenuse side. Goed, so dis nou soms 'n bietjie addisioneel, as jy dit kan onthou. Moet net nie dink daai gaan nou 3 wees, omdat dit 4, 5 en 3 is nie. Die 5 moet op die skynsy sit, dan is dit die goue verhouding. Alright, if you can remember that for later on, wonderful. So in this case as well, if you saw from the start 3 and 4, this is 5. I would be very proud of you if you knew that it was 5 immediately without writing all of this. Only for the 3, 4, 5 triangle. Now that we've got the 5, now I can say, listen, I'm going to now work in triangle ACD. Nou gaan ek in die boonste driehoekie werk en ek sê vir die juffrou, listen ma'am, I'm now working in triangle ACD. And in that triangle, can I use Pythagoras? Yes, because that angle C there, and we call it ACD, or you can call it C1 if you want to. C1. Why? Because there's another one. So dan is dit mos goed dat ek sê ek is besig met daai enetjie. Of ACD, that's another way of writing it. Get the way of writing correct as well. Jy moet die goeders asseblief reg skryf. So jy kan of praat van hoek C1 of van ACD of DCA, but remember there is the angle. And that angle is 90, want dit is weer gegee. And because it is given, I have the way of right. Ek kan binne ingaan met my kaartjie vir Pythagoras. Is it the hypotenuse side I'm looking for? Hierdie sy wat jy voorsoek, is dit die skynsy? Yes, it's hypotenuse because it's opposite the 90. So because it's hypotenuse, it will be the sum of. Omdat die skynsy is dit die som van. As dit nie die skynsy is nie, is dit 'n minus som. And if it's a minus sum, the first, not a minus sum. If it's a minus sum, the first one has to be the hypotenuse side. Moet die skynsy wees as dit 'n aftrek sommetjie is. Goed. Hierheen was nou weer 'n som van, so of ek nou ACCD of anders omgeskryf het, but this is not right unless it's the square. Want dis die square on the hypotenuse is equal to the sum of the squares on the other two sides. Dis nie die skynsy is gelyk aan die som van die ander twee nie. That's not true. 3 and 4 doesn't give me 5. The sum isn't equal to this line. It's the square is equal to the sum of the squares. So if I add those together, then AC was 5 and CD was 8. And when I do my sum, I get 5 squares 25, 8 squares 64, so it's 89. So then to get my, let's do it all accurately. To get the square root of that, what times what is 89? And we go to our calculator and we say root of 89 and it gives me 9.43. Because it was 9.433, so it won't go higher because the next 3 doesn't change this one. So AB was 9.43. Remember to read your question. The question was to prove AC, AD. I got AC, I got AD. Am I finished with my sum? I've got everything that they asked before. I'm working out sides. Waarvoor is Pythagoras? Om sye uit te werk. What do I work out with Pythagoras? Sides. I have to have 2 sides and I'll get the third one. Goed, jou huiswerk, jou homework is exercise 15.3, oefening 15.3. Die een sommetjie is net 'n gewone sommetjie waar jy weer een sy moet uitwerk. One sum has to be worked out. And then this is one like the example where there are 2 triangles and you've got to work out more of the sides.